Welcome to the Grid Research Summit. Tell me your name and who you worked with and where you went.
Okay, so my name is Xabriel Collazo-Mojica. I'm a PhD student back at Florida International University. For this CI-PIRE, I work with Dr. Rosa Badia and Jorge Jarque from the Barcelona Supercomputing Center. My advisor is Dr. Masu Sayade, by the way. The title of my project is Cloud Application Mapping and Scaling based on monitoring of quality of service requirements. So the idea and the problem statement is, so cloud computing provides you with this illusion of infinite capacity, right? And the way that they do this is some specific key enabling technologies, but specifically they use virtualization, right? And these infrastructure as a service providers, what they provide you is raw computational resources. So they provide you with CPU time, they provide you with RAM, and some specific network bandwidth, right? And they bundle this in specific target prices. So for example, Amazon EC2, which is a provider of these services, they will provide you instance type, what they call instance type, which is a micro instance type, will provide you this amount of CPU, this amount of RAM, and this amount of network. And if you scale up for an extra large instance, for example, then you will have more resources, more CPU time available, more RAM, and more network, right? So the problem here is that solution developers, so I'm going to try and build an application, a cloud application, and then I want to map the components of my application to these resources, to these cloud resources. So the first thing that you come up with is the image, right? So that you can put that on what we call the virtual machine, and then the virtual machine will run on top of these resources that Amazon, for example, is listing to you. So how do we do that mapping, right? So given an application architecture, some quality of service constraints that you want to ensure, right? And then given a specific workload, then I want to compute which one of these bundles is the correct one for my application.
So how did you go about attacking this problem? What was some of the methodology used?
Okay, so the idea, it's kind of like an autonomic solution, and we have the sensors in this case will be that we will be benchmarking the application. So we put the application on all of the permutations available. For example, in Amazon, you could put an application in a micro, small, large, or extra large instance, right? And then we see the behavior. And we have a kind of like a black box, which is a learning algorithm. In my case, I'm using linear regression for that, which sees how is your application behaving on some specific target measure, and then we are specifying quality of service constraint. And in specific for this example here, we are talking about the response time of an application. So you have these sensors that see how your application behaves throughout a workload, and then we get the knowledge in this black box that's doing some type of machine learning, and then the actuators in this case are the mapping. So the mapping that I try to tell you, okay, so given the workload and given the quality of service that you want to ensure, then I tell you, okay, so then you should go with this specific mapping.
So what are some of the outcomes at this point, and what is some of the future work that you want to work through?
So for the CI-PIRE term, we were able to discuss various ideas of how this machine learning module, so how to go about it, right? So we present the design and development of the solution, right? And then we also present some details in the poster and then in an upcoming paper. So for future work, we're trying to see how we will go about validating the idea. See, because so you need some kind of statistical measure that, for example, the one that I'm using is average response time in this case, but that might not be sufficient for some type of workload, right? Because there are some outliers that we might need to cover. So for future work, what we try to do is that we will try to improve the way that we do the mapping, and also to scale up the experiment size. was just for two component-based architecture.
And tell us a little bit about your international experience.
Oh, great. I was back there with Rosa Badia's team in the Barcelona Supercomputer Center. That's back in Barcelona. Barcelona is the capital city is Catalonia, and it's a really nice city, very cosmopolitan. So I had the opportunity to work with Rosa's team, and they've been working on high-performance computing for a long time. So all of their feedback was closely related to what on my problem definition, and then in general. So I think being abroad always opens your mind and your eyes to different different situations that you have in different cultures. But being specifically in Barcelona was really great because they were having a kind of like a rare summer where they will be having 75 degrees days, so they were just perfect. Really bright sun, but it was really nice to go to the beach.
Excellent. Well, I'm glad you had a very good research experience. Thank you for your work. It was great.
Oh, thank you.